So today we'll be learning organic chemistry, which for us in medical school we deem as basic medical chemistry. Now first of all, we want to look at what chemistry is. We understand that chemistry is the experimental study of the nature, properties of compounds, their composition, and then the reactions they undergo. And organic and chemical or chemistry, we have three main branches. The first branch is physical chemistry. The second branch is inorganic chemistry. And the third branch is organic chemistry, which is our focus for today. Now, organic chemistry by definition does not differ so much from the general definition of chemistry. Organic chemistry is the study of carbon compounds, their nature, their properties, and then their interrelationship with other atoms or carbon compounds, and even with other atoms. So we see that organic chemistry, we are studying carbon compounds. We want to study their nature, we want to study their properties, and their interrelationships with other atoms. Now, somebody would even ask, why are we so much concerned with studying of carbon compounds whilst there are other compounds to study? Now, it all boils down to the fact that carbon form part of the group 4 elements. And you know group 4 elements have 4 electrons on their valence or on their outermost shell. So anytime they have 4 valence electrons. And these valence electrons, they can't donate and they can't also accept 4 electrons to form an octet or to complete their octet shell. So what they do is that they share electrons, they contribute electrons to form a stable bond. And because carbon is very small, it is the smallest member. Carbon is the smallest member of the group 4 element. Its bonding is so close to the nucleus, and so it is able to form strong bonds. So the reason why we are studying carbon is because it is able to form strong bonds. And then 2, because of its tetravalent nature, so tetravalence, which is because it has 4 valence electrons. And then the third thing is that carbon can also form single and multiple bonds. By single bonds, we mean the ones that we see in saturated compounds. And then by multiple bonds, we mean double bonds and then triple bonds, as seen in unsaturated compounds, organic compounds. Sometimes, or oftentimes, people tend to confuse organic chemistry, these properties, such as the formation of strong bond, the tetravalency, and then even the formation of single and multiple bonds, with the fact that we are studying organic chemistry because of isotopy. No, we don't study organic chemistry because of isotopy. In fact, isotopy falls under physical chemistry. We don't also study organic chemistry because of allotropy. No, we don't study organic chemistry because of allotropy. These are all under physical chemistry. Now, even in as much as that we've said that organic chemistry is the study of carbon compounds, we don't study some compounds, and these compounds are compounds containing carbonates, cyanides, and then the oxides of carbon. So oxides of carbon. Because in fact these ones are all inorganic in nature. And so we probably will study these ones. We probably will study 1, 2, 3 under inorganic chemistry. So for carbonates, let me just represent them with 2 minus, and then the cyanide 2 minus. 2 minus. Yes. Now, we have 4 branches or 4 classes under organic chemistry. Now let's look at organic chemistry and the classes. I have a very little space, so you have to be writing alongside. Now, we are looking at classes of organic chemistry. Classes of organic chemistry. Now we have 4 main classes. These classes are 1. Aliphatic compounds. We have aliphatic compounds. We have 2. Aromatic compounds. Aromatic compounds. We have 3. Alicyclic compounds. Alicyclic compounds. And then 4. We have heterocyclic compounds. Heterocyclic compounds. Now, let's take them one by one. Aliphatic compounds. These are organic molecules, or these are organic molecules that are arranged in open chains. Now, in organic chemistry, if we talk about open chains, what we mean is they are either branched or straight. So that is a subset. So anytime we talk about open chains in organic chemistry, we are actually talking about branch or straight. So let me give you an example. Imagine we have a compound containing 4 carbon atoms and then 10 hydrogen atoms. This compound can be written as, let me just draw the structure for you, C, 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 with H bonding to H bonding to H. Now this is a straight chain. This is butane. We will learn the classification, we will learn the nomenclature of these compounds. But just for the intro, we have to go this way. And then we also have a compound like this. Now, this is an open chain or an alicyclic compound. If you look here, you realize that there is a branching here, right? If you also go this way, you can also see that this actually becomes a branch. You still don't get it, right? Now let's number. If you want to number, we number the longest continuous carbon chain. So we can go 1, 2, 3. This can be our longest continuous carbon chain. We can also go 1, 2, 3. So in either ways, branching, what we call a branch, can also be a straight chain. And so for the correct description of alicyclic compounds, we see that they are compounds that are arranged in straight chains. Okay, yes, and this is 2-methyl propane. 2-methyl propane. We've not done the nomenclature of organic compounds. We'll do that in our later peer tutoring videos. Now, we move to another thing, which is aromatic compounds. Now, for aromatic compounds, these are compounds that are recognized by a 6-membered ring. Okay, so aromatic compounds. Aromatic compounds. They are recognized by the 6-membered ring of carbon atoms. And this ring is actually the benzene ring. And so anytime you see, I think the structure is not clear. Anytime you see a compound containing benzene, this is benzene, then that compound is said to be aromatic. Now let me give you an example. An example is this compound called toluene, CH3. This is called toluene. Toluene is an organic compound. Another example is when you have a compound with another functional group, the COH functional group. This compound is called phenylmetanoic acid or benzoic acid, phenylmetanoic acid. These are all organic. These are all aromatic compounds, right? We can add different examples. Even when you have another CH3 here, this then moves from toluene to become a xylene. We will learn the nomenclature of these compounds. But whenever we talk about aromatic compounds, they are recognized by the 6-membered ring of carbon atoms with a delocalized ring of pi electrons, and that is simply benzene. So anytime you see benzene in a compound, that compound deemed fit to be called an aromatic compound. Another thing that we'll be looking at is an alicyclic compound. An alicyclic compound. Alicyclic compounds. Now, alicyclic compounds. Now, for alicyclic compounds, they contain carbon atoms in close rings. So, let me just say, carbon atoms are arranged in closed rings. We said that aliphatic compounds are arranged in open chains, and we are seeing that these ones too are arranged in closed rings. And let's look at an example. We have a compound like this, where we have carbon here, carbon here, carbon here, carbon here. And we name these compounds, or they are recognized by the name cyclo. So anytime you see a compound like this, is a cyclobutane. So cyclobutane, because it has 4 carbon atoms. 4 carbon atoms. And the fact that it's in a closed ring, this is a cyclobutane. You can have different examples. They can contain saturation or unsaturation. And so you can also see a compound like, let me do this. A compound like this. This is also cyclopropane. Even this compound, we can introduce saturation here. And then, because this saturation qualifies it for a functional group, alkene, this then becomes cyclobutene. So that is, we are not learning nomenclature, so I'm not going to teach you how to name these compounds until we get to that session, okay? Yes, but for now, just know that these compounds are recognized by the close ring. Now let me give you an example. Because you were looking at aromatic compounds, I didn't draw this structure for benzene, and I think some of you get confused. This structure is actually an alicyclic compound. It was a proposed structure for benzene, but in fact, this is actually 1. If we start naming from here, 1, 2, 3, 4, 5, and then 6. This is actually 1, 3, 5 cyclohexa, because it contains 6 carbons, so hexatriene. This is actually an alicyclic compound with saturation with alternating double and single bond. This is a proposed structure by an organic chemist known as Frederick Kekulé. This is his proposed structure. And so don't confuse yourself. We'll get to the nomenclature and then we'll treat it there. We'll treat everything there. Now, for the last class of organic compounds, they are known as heterocyclic compounds. Heterocyclic compounds. Now, for heterocyclic compounds, they are arranged in close ring. Just that note, there is an atom other than carbon in the close ring. So even though we have the close ring, but we have an atom other than carbon present in the ring, And mostly these atoms that are present in the ring are known as SON. S-O-N. So SON, this is for sulfur, this is for oxygen, and this is for the nitrogen atom. They are easily present within the close ring. Let me give you an example. An example is thiophene. So we have a compound like this with S. And this compound is known as thiophyllene. We also have furan. You can check examples of heterocyclic compounds on the internet, and you get a lot of them. This is furan. There are a lot of them. There are a lot of them on the internet that you can search and learn from. So once again, this is an intro video to organic chemistry as a branch of chemistry and its classes. Thank you. Subscribe to our channel. Bye.